Hello, let's look into today's Leetcode problem, which is move pieces to obtain a string. In this question, you are given with a start string and target string. Your end goal is to convert start string to target string, and you are allowed to do certain set of operations, and those operations are mentioned over here. I will simply demonstrate with an example to make things a little more clearer. So what they want us to do, the set of operations that we are allowed to do here is, if you, okay, first thing is the string can either have these three values, L, R, or empty strings, empty character. So if you are able to find any index that has L as a value, and if you find a left neighbor that has empty space, then you will be able to shift the value towards the left. That is possible for any index that has value set to L, and vice versa. For any index that has value set to right, R, and if the right neighbor is empty, then you can shift the value towards the right position. There could be scenarios where you have a string like this, and not like this, and here you won't be able to move R towards the right or left, L towards the left, because R's right neighbor is not empty space. Similarly for L, the left neighbor is not empty space, so you won't be able to do anything in such scenarios. Okay, so if you try looking into all three examples of this question, right, you will be able to figure out few edge cases or few necessary conditions that needs to be taken care of. Let's try looking into one another example. And the example goes like this. We have one R and L. Let's say we have something like this as well. We have something like this. So one thing that you should observe here is the relative ordering. First things first, you won't be able to convert the start string to target string. That's because of the condition that I mentioned previously. So one thing that you should observe here is the relative ordering of the strings matter here. If you simply ignore the empty spaces for both start and target string, and try making a string out of them, then if they are not equal, which means that you won't be able to convert the start string to end string. So here R and L will be a string which when ignored of empty spaces will get formed, and for target string things will look like this. And like I said, you won't be able to do swaps if you encounter a situation like this. So this is not possible. So that is one of the conditions that you should keep in mind. The other two conditions that should be taken care of is this one. So let's say we have an input like this, and we want a target like this. In such scenarios, you won't be able to shift R because it's already shifted towards the extreme right. Similarly for L as well, if you encounter a start index like this and end index to be like this, then L can only get shifted towards left right, or let's say like this. It cannot go towards the right. So in such scenarios as well, you won't be able to achieve the target string, and you should simply return false. Okay. So enough talking here. Um, what you can do for these kind of solutions is try to iterate for each of the index present in start string, and do shifting and try to make the start string equal to end string. But this solution will take you n square time complexity, and that's we can do something better than that. Actually, we can finish this solution in big of n itself, and here all you need to do is return true or false, right? So you don't really need to do shifting of our our start string towards the target string. You can simply check if it's possible or not to convert start string to target string and simply return our value. So that is one hint that they have given here, which is like all you need to do is return true or false instead of calculating the operations or finding the steps to go towards the target or something like that. Okay, And two other unique cases will be something that I already discussed. So if we try to keep these things in mind, we will be able to arrive to our solution. And the other thing that you should keep in mind is we only have L, R or empty spaces in our start and target string. If we are able to validate correct places of L and R in our string, right, then automatically the alignment of spaces will be correct as well. Okay, so for this solution, we can simply use two pointer approach. We can have a pointer for start and a pointer for end. We can try iterating over both of the start and target string on non-empty spaces. Like I said, if we are able to find a valid case for valid relative ordering for the start and target, then we will be good, along with the two other conditions that I mentioned. So let's say our first pointer points towards our non-empty index, and here as well jth pointer is pointing towards our non-empty index. Both of them are equal, then we can simply proceed. If both of them are not equal, then you simply break and return false. That is one thing that you can do. And if they are equal, you move one step ahead. I will go here, J will go here. We check both of them are equal. Then we move forward again. I will go here, J will go here. Both of them are equal. The relative orders are good. But here we are ignoring two other conditions. Like I said, let's take one more example where relative ordering is same, but you might not be able to arrive into a solution. So um, this is our start string and this is our target string. Here I is in the n minus 1th index and here j is in the 0th index. So I is clearly greater than j for r for r, and similarly for L it will be something like this. So here you can see I is lesser than j for L. So these three conditions, right? One is a condition like this, second one is a condition like this, and third one is checking if the relative ordering is correct or not. If these three conditions are met for all of the our searches, then we will be able to convert our start string to end string. If any one of these conditions are not satisfied, then we simply break and return false. That's how the code looks like. In this solution, I have simply iterated over the target and start string, and what I did was find the index that doesn't have empty space, the relative indexing basically. And if any one of these conditions are not satisfied, like I said in our demonstration, then you simply break. And after breaking, what you need to check is if both the pointers have returned to like have completed their search. If they have completed their search, then you simply return true. And if they haven't, which means that it got into some break condition, and you simply return false. So that's how the code looks like. Here, it is necessary to have these two conditions as well, because I can come across an example where things might not be correct. Let's say this is one of our example, and this is our start string and this is our end string. Here I and j position are compared, well and good, but after that j reaches towards the end and I doesn't reach towards the end. So in such scenarios you won't be left with any comparison. That's why we have these conditions as well. If any one of them is equal to n, if any one of them reach, complete their search space, then you simply return, then you simply break. In valid or true scenarios, both of I and jth pointer will complete their search at the same time. If not, then we simply break and check if the search spaces are completed properly. And yeah, that's pretty much it. If I try submitting this solution, right, it will work. Okay, it is not working. I might have missed something. Um, let's try comparing and checking if things are good here. I was doing some experimentation before, you know, following up on a video. They look correct to me. Let's try to submit it again. It works. It's kind of vague. I'll figure it out. And yeah, the main thing is the logic understanding. If you're able to understand that properly, then I think my job is done. So yeah, thanks for watching. Bye bye.